I'm going to tell you something that might disappoint you. Nobody ever figures out what life is all about, and it doesn't matter. Explore the world. Nearly everything is really interesting if you go into it deeply enough. You were expecting wisdom, right? You were expecting me to stand up here and give you the answers, the meaning of life, the purpose of the universe, the secret to understanding everything. Sorry, I don't have that. Nobody does. And anyone who tells you they do is lying to you or lying to themselves. But here's what I do have. I have curiosity. I have questions. I have this burning need to look at things and figure out how they work. Not because I think I'll ever reach the bottom, but because the looking itself is fun. It's play. That's all science really is, you know? Playing with the universe. Most people think science is serious business. Men in white coats, complicated equations, speaking in jargon nobody understands. And sure, there's some of that. But at its heart, science is just playing around. You poke something. You see what happens. You ask, what if I do this? And then you try it. That's how I've always worked. I look at something and I think, that's interesting. I wonder how that works. And then I just play with it. I take it apart in my mind. I rebuild it. I try to understand it from every angle. Not because I have to, because I want to, because it's fun. When I was a kid, my father took me for walks in the woods, and he taught me something that I carried with me my whole life. We'd see a bird, and he'd say, "See that bird? It's a brown-throated thrush, but in Germany it's called a Halsenvogel, and in Chinese they call it a chungling, and in Japanese a whatever. You can know the name of that bird in every language in the world, and when you're finished, you'll know absolutely nothing about the bird. You'll only know about people in different places and what they call the bird." Then he'd say, "Now let's look at the bird. What's it doing?" And that's the difference between knowing the name of something and knowing something. I learned very early the difference between knowing the name of something and knowing something. Most education is about names. You go to school, they teach you the names of things. Quantum chromodynamics, the Krebs cycle, differential equations, and you memorize these names, and you feel smart because you can say them. But you don't know anything. You just know labels. Real knowledge is different. Real knowledge is when you look at the bird and you notice it's pecking at the bark in a particular way, and you realize it's looking for insects, and you wonder how it knows the insects are there, and you start thinking about what senses it might be using, and suddenly you're not memorizing labels anymore. You're actually looking at the world. That's what I try to do when I explain things. I try to show you the bird, not tell you its name. Here's something that makes a lot of people uncomfortable. I can live with doubt and uncertainty and not knowing. I think it is much more interesting to live not knowing than to have answers that might be wrong. People don't like that. They want certainty. They want someone to tell them, this is how it is, this is the truth. They want to feel secure in their knowledge, but the universe doesn't care what makes you comfortable. The universe is what it is, and it's full of uncertainty. I'm a physicist. I've spent my whole life studying the universe, and you know what? There's so much I don't know, so much nobody knows, and I'm okay with that. More than okay. I think it's exciting, because it means there's always more to discover, always another layer to peel back, always another question to ask. The first principle is that you must not fool yourself, and you are the easiest person to fool. This is so important, I can't stress it enough. You lie to yourself constantly. You pretend you understand things you don't. You use complicated words to hide your confusion. You convince yourself you've got it figured out, when really you're just scared to admit you're lost. I've done it. Everyone does it. But you have to fight against it. You have to be honest with yourself about what you actually understand and what you're just pretending to understand. Because if you fool yourself, you'll never learn anything new. You'll just keep walking in circles, convinced you're making progress. Let me tell you about quantum mechanics. I think we can safely assume that no one understands quantum mechanics. Now, I say that as someone who won a Nobel Prize for work in quantum electrodynamics. I can calculate with quantum mechanics. I can predict what will happen in quantum systems with incredible accuracy. I can teach it. I can use it. But understand it? No. Nobody does. Here's the thing about quantum mechanics. Relativity. That's weird too, right? Time slows down when you move fast. Space curves near massive objects. That all sounds crazy. But once you work with it for a while, you can kind of feel it. You develop an intuition for it. It stops feeling quite so alien. Quantum mechanics? Never. I've been working with it for decades, and it still feels completely bizarre. An electron doesn't have a position until you measure it. It's not hiding somewhere waiting for you to find it. It's in a superposition of all possible positions simultaneously. And the moment you measure it, the wave function collapses, and it's suddenly in one place. What does that mean? How does that work? Why does measuring it change things? I don't know. I can tell you the mathematics. I can show you how to calculate the probabilities. But I cannot give you a picture of what's really happening that makes intuitive sense, because it doesn't make intuitive sense. It can't. Our brains weren't designed to understand quantum mechanics. Our brains were designed to help us not get eaten by lions on the African savannah. But here's the beautiful part. Even though we don't understand it, we can still work with it. We can still use it. We can still build incredible technology based on it. Understanding and calculating are two different things. Other physicists, they try to smooth over the weirdness. They try to make it sound reasonable. Think of the electron as a wave. No, think of it as a particle. They give you metaphors and analogies to make you feel better. But those metaphors are lies. Useful lies, maybe, but lies. I'm not going to lie to you. The electron is not a wave. It's not a particle. It's something else entirely. Something that sometimes acts like a wave and sometimes acts like a particle, depending on what you're measuring. And I can't explain what that something else is, because we don't have words for it. We don't have concepts for it. All we have is the math. You know what was written on my blackboard when I died? What I cannot create, I do not understand. That's my philosophy of learning. If I can't rebuild something from scratch, if I can't take it apart and put it back together in my own way, then I don't really understand it. I'm just parroting someone else's understanding. Throughout my career, I would take entire fields of physics and rebuild them from the ground up in my notebooks. Quantum mechanics, electromagnetism, statistical mechanics. I'd start with the basic principles and work my way up, putting everything in my own words, my own notation, my own way of thinking about it. Why? Because that's how you really learn. Not by memorizing what someone else thought, but by thinking it through yourself, by struggling with it, by making mistakes and correcting them, by building your own mental machinery. I don't know what's the matter with people. They don't learn by understanding. They learn by some other way, by rote or something. Their knowledge is so fragile. I see this all the time in students. They memorize formulas. They practice problem types. They can solve the exact problems they've seen before. But you give them something slightly different, something that requires them to actually think, and they fall apart. Because they never really understood. They just memorized patterns. That's cargo cult science. You know this story? During World War II, the Americans built air bases on islands in the Pacific. Planes would land, bring supplies, then leave. The islanders saw all this. After the war ended, they wanted the planes to come back. So they built fake runways out of bamboo. They made fake airplanes out of straw. They wore fake headphones made from coconuts. They were copying the form of an airport, hoping it would bring back the planes. But they didn't understand how airports actually worked. They were just imitating the surface features without understanding the underlying mechanism. That's what most education does. It teaches you to build bamboo runways. You memorize formulas without understanding where they come from. You solve problems without understanding why the methods work. You're just going through the motions, hoping the planes will land. Real understanding is different. Real understanding means you can build the airport from scratch. You know why each piece is there. You know how it all fits together. And when something breaks, you can fix it, because you understand how it works. Here's something I believe deeply. What one fool can learn, another can. I'm serious about this. People act like physics is this incredibly difficult thing that only special geniuses can understand. That's nonsense. Everything in physics was figured out by humans. Regular humans. Humans who made mistakes, who got confused, who had to struggle with these ideas just like you do. And if they could figure it out, you can too. I'm smart enough to know that I'm dumb. That's one of my secrets, actually. I know I'm not some superhuman intellect. I'm just a guy who's really, really curious and too stubborn to give up on problems. That's it. That's the whole secret. When I won the Nobel Prize, people started treating me differently. Like I was some kind of oracle. Like I had access to special knowledge nobody else could reach. And I hated it. Because it's not true. I'm just a fool who spent a lot of time thinking about physics. And what one fool can do, another can. You don't need to be extraordinary to understand the universe. You don't need some special gift. You just need to care enough to actually look, to actually think, to actually struggle with the ideas until they make sense to you. I've never cared about credentials or titles or who's important and who's not. If you have a good idea, I'll listen, whether you're a Nobel laureate or a freshman undergraduate. And if you have a bad idea, I'll tell you it's bad, no matter who you are. The universe doesn't care about your resume. You remember when I was on that commission investigating the Challenger disaster? All these NASA officials, all these engineers, they were talking in this careful political language. Nobody wanted to say what actually happened. So I took a piece of the O-ring, the rubber seal from the rocket booster, and I dropped it in a glass of ice water during the hearing, on television, and I showed everyone that the rubber became brittle in the cold. That's it. That's what caused the disaster. The O-rings got too cold, they got brittle, they failed. Simple, clear, obvious once you looked at it. But nobody wanted to look at it. They wanted to talk around it, use technical jargon, avoid blame. I just wanted to show people the truth. You don't need fancy language. You don't need political dancing. You just drop the rubber in the ice water and show people what happens. Here's something I need to tell you, and it's important. Physics isn't the most important thing. Love is. People are surprised when I say that. They think, but you're a physicist. You spent your whole life on physics. And that's true. But physics is just stuff I do because it's interesting. It's not what makes life worth living. The highest forms of understanding we can achieve are laughter and human compassion. Not mathematical understanding, not scientific knowledge. Laughter and compassion. Those are what connect us to each other. Those are what make us human. I've always tried to be funny when I teach. Not just to entertain, though I enjoy that, but because humor is a form of understanding. When you laugh at something, you're seeing it clearly. You're cutting through the pretense and seeing what's actually there. I'd make jokes about quantum mechanics, about how absurd it is that particles can be in two places at once, about how the universe seems to be playing a cosmic prank on us. And in that laughter, in that moment of seeing the absurdity, you understand something real about how strange the universe actually is. But I never forgot that at the end of the day, we're not just brains trying to understand equations. We're people. We fall in love. We lose people we care about. We experience joy and sadness and wonder. And all of that matters more than any equation ever will. I've always been aware that I'm a universe of atoms, but also an atom in the universe. I'm made of the same stuff as stars, the same quantum fields, the same fundamental forces. In that sense, I'm nothing special, just another arrangement of particles. But I'm also conscious. I can look at the universe and try to understand it. I can appreciate its beauty. I can share that appreciation with others. And that's something remarkable. That's something worth celebrating. You know what I really love about science? It's that every answer leads to more questions. You solve one puzzle, and you find 10 more puzzles underneath. It never ends. The mystery never goes away. It just gets deeper and more interesting. People think the goal of science is to answer all the questions, to figure everything out, to reach some final theory of everything where there are no more mysteries. But that's not how it works. That's not how it's ever going to work. The universe is too complex, too strange, too wonderful for us to ever fully understand. And that's okay. That's more than okay. That's perfect. Because it means we'll always have something to discover. Always another question to ask. Always another mystery to explore. I would rather have questions that can't be answered than answers that can't be questioned. That's the scientific spirit. Stay curious. Stay skeptical. Never assume you've got it all figured out. Because the moment you think you understand everything is the moment you stop learning. The universe is under no obligation to make sense to you. It's not trying to be understandable. It's not trying to be intuitive. It just is what it is. And our job is to figure out what that is, as best we can, using whatever tools we have. Sometimes those tools are mathematical. Sometimes they're experimental. Sometimes they're just our brains, trying to visualize what's happening in ways that make sense to us. But all of those tools are imperfect. All of them are limited. And that's fine. We work with what we have. Let me tell you about something that happened when I was working at Los Alamos during the war. We were building the atomic bomb, right? Very serious business. Life and death. The fate of the world. Heavy stuff. And I was miserable. Not because of the moral weight of what we were doing, though that was there, but because I'd stopped having fun with physics. I was just grinding through calculations, solving problems because they needed to be solved, not because I was curious about them. Then the war ended, and I went to Cornell to teach, and I was still miserable. I'd sit at my desk, trying to work on important problems, significant problems, problems that would advance the field, and I couldn't do anything. I was completely blocked. Then one day, I was in the cafeteria and some kid was fooling around, throwing a plate in the air, and I noticed something. When the plate wobbled, it spun, and there was a relationship between the wobbling and the spinning. The wobble was faster than the spin by some factor, and I thought, that's interesting. I wonder what that factor is. So I worked it out, just for fun, not because it was important, not because anyone asked me to, just because it was a fun little puzzle. I showed it to Hans-Peter, and he said, Feynman, that's very nice, but what's the importance of it? And I said, it has no importance. I'm just doing it for fun. But here's the thing. That fun little problem about the wobbling plate, it led me to think about the rotation of electron spins, which led me to think about quantum electrodynamics, which led me to the work that eventually won me the Nobel Prize. All because I gave myself permission to play again, to work on things just because they were interesting, not because they were important. That's what I want you to understand. The best work, the most creative work, comes from play, not from grinding away at important problems, but from following your curiosity wherever it leads, even if it seems silly or trivial. You know what I love about teaching? It forces you to really understand things. You can fool yourself when you're working alone. You can skip over the parts you don't quite get. But when you're teaching, when someone asks you a question, you can't fake it. You have to know it cold. I used to teach introductory physics at Caltech, and people would ask me, why are you, a Nobel Prize winner, teaching freshman physics? Shouldn't you be doing research, teaching graduate courses? And I'd tell them, if I can't explain something to a freshman, then I don't really understand it myself. And that's true. The basic stuff, the foundational stuff, that's the hardest to explain, because you can't hide behind jargon. You can't wave your hands and use fancy mathematics. You have to make it clear and simple and intuitive, and that requires deep understanding. I remember once a student asked me why spin 1/2 particles obey Fermi-Dirac statistics, and I realized I couldn't give a good answer. I could give the mathematical answer, sure. I could show the equations, but I couldn't explain it in a way that would satisfy a curious freshman. So I told the student, I'm going to prepare a lecture on this. Give me a few days. And I went away, and I tried to work out a simple explanation. I spent days on it. And finally I came back, and I told the student, you know what? I can't explain it. We just have to accept it. It's one of those things we've learned about the world, but we can't reduce it to anything simpler. That honesty is important. Sometimes the answer is, we don't know why. And that's okay. That's where we are with our understanding. Pretending otherwise doesn't help anyone. People ask me, what drives you? What makes you keep working on these problems? And the answer is simple. It's fun. Finding things out is fun. Understanding how something works is one of the greatest pleasures there is. When I was a kid, I used to fix radios. People would bring me their broken radios, and I'd take them apart and figure out what was wrong and fix them. And I loved it. That moment when you suddenly understand what the problem is, when the pieces fit together in your mind, that's a rush. That's better than anything. Physics is the same thing, just on a cosmic scale. Instead of fixing radios, I'm trying to figure out how the universe works. And every time I understand something new, every time I figure something out, I get that same rush I got as a kid fixing radios. That's what science should be about. Not about prestige or awards or being the smartest person in the room. About the pure joy of understanding, of figuring things out, of seeing how the pieces fit together. I've won prizes. I've gotten honors. People know my name. But none of that matters as much as the feeling I get when I finally understand something that was confusing me. That moment of clarity, that aha moment, that's the real reward. But there's another side to this. With knowledge comes responsibility. I learned this during the Manhattan Project. We built the atomic bomb. We created something terrible and powerful, and we had to live with that. After the war, I went through a period where I couldn't see the point of anything. We'd built this weapon that could destroy cities, that could end civilization, and I thought, what's the point of building anything if it can all be destroyed? But eventually I realized something. You can't stop progress. You can't put knowledge back in the box. Once we know how to split the atom, that knowledge exists. The question is what we do with it. And the answer, I think, is that we have to be honest about what we know and what we don't know. We have to be clear about the consequences of our actions. We have to be willing to say, this is dangerous. This could go wrong. even if people don't want to hear it. That's what I tried to do with the Challenger investigation. The engineers knew the O-rings were a problem. They'd known for years, but the pressure to launch was enormous. The political pressure, the financial pressure, so they convinced themselves it would probably be okay, and 7 people died. That's what happens when you fool yourself. When you let what you want to be true override what you know to be true. The universe doesn't care about your budget or your schedule. It just does what it does, and if you ignore that, people get hurt. So part of understanding the universe is understanding our limitations, understanding that we're fallible, that we make mistakes, that we have biases and blind spots, and being honest about all of that. After all these years, after all the problems I've solved, after all the lectures I've given, you know what? The universe still amazes me. Every single day. I look at a glass of water, and I think about all the molecules bouncing around in there. Billions and billions of them. Each one a little quantum system obeying the laws of physics. And somehow, out of all that chaos, out of all that complexity, we get this smooth flowing liquid that I can drink. That's miraculous. That's wonderful. And I never get tired of thinking about it. Or I look at the stars at night, and I know that the light hitting my eyes left those stars thousands or millions of years ago. I'm seeing the past. I'm looking back in time. And the atoms in my eyes, the atoms that are absorbing that light, were made in stars like those. We're made of star stuff, as Carl Sagan liked to say. That sense of wonder, that sense of connection to the cosmos, that never goes away. No matter how much you learn, no matter how deeply you understand, there's always something new to marvel at. Some people think that understanding takes away the magic. They think that once you know how something works, it becomes mundane. But that's backwards. Understanding adds to the wonder. It doesn't subtract from it. When you understand that a rainbow is caused by light refracting through water droplets, each droplet acting like a tiny prism, separating white light into its component colors, and that different angles give you different colors, and that's why the rainbow is always the same sequence of colors. That doesn't make the rainbow less beautiful. It makes it more beautiful, because now you understand the machinery behind the beauty. So here's what I want to leave you with. The universe is strange. It's beautiful. It's full of mystery, and you don't need anyone's permission to try to understand it. You don't need credentials or degrees or special gifts. You just need curiosity. You need honesty, especially honesty with yourself about what you do and don't understand. You need persistence, and you need to be okay with not knowing, because there's going to be a lot you don't know. But that's the fun part. That's where the adventure is. In the questions, in the mystery, in the process of trying to figure things out, knowing you might never get to the bottom of it. I've spent my whole life playing with the universe, poking at it, asking it questions. Sometimes it answers, sometimes it just confuses me more. But it's been the most fun I could possibly have. The key is to never lose that sense of play. Never let science become drudgery. Never let the pressure to be important or significant crush your natural curiosity. Work on what interests you. Follow the questions that excite you, even if they seem trivial, even if no one else cares, because you never know where those questions will lead. That wobbling plate in the cafeteria led me to quantum electrodynamics. Your silly little question might lead you somewhere amazing. And even if it doesn't, even if it just leads to understanding one small thing about the world, that's enough. That's valuable. That's worth doing. So go play, go explore, go ask questions. And don't let anyone tell you that understanding the universe is only for special people. It's for everyone. It's for anyone who's curious enough to look. What one fool can learn, another can. And we're all fools together, trying to make sense of this bizarre, beautiful, mysterious universe we find ourselves in. And honestly, I wouldn't have it any other way. The universe doesn't owe us understanding. It doesn't owe us comfort or certainty or easy answers. But it does offer us something better. The joy of discovery. The thrill of figuring things out. The satisfaction of understanding, even if that understanding is incomplete and temporary. That's enough for me, and I hope it's enough for you too.